So today in this video we will see how Smith chart works. For example, you are given a point here, small zl, which is equal to 60 plus j50 and z0 is 50 ohms. Now what will you do? You will divide them. When you divide them, you will get capital ZL, which will correspond to a value of, it will become 1.2 plus J 1 ohm. So you will now locate this point on Smith chart. So what is Smith chart? Smith chart is a representation of your values of ZL, Zn standing wave ratio, because the formulas of Z and ZL are quite complicated. So Smith charts is like a tool which helps you to find them on that whole chart rather just using formulas. So now we will locate that point 1.2. It starts from here and it goes till here. So this is your 1.2 on real axis and on that point, so it is your 1.2 and 1. Okay, you have now first located this point. Now what will you do? Now you have to draw a line from origin here. It's my scale. So you have to, I want to do precise calculation, that's why it will take some time. Here, now I will draw that line here from origin. Origin here is your point 1. So line is drawn here. Now you will have to draw a circle. You have to take a compass, place center at point 1 and pencil at here at blue point, then make a circle. But now I do not have that circle feature in this system, so I will just locate that points where it intersects. It intersects here and at 2.5 part. Just it passes through this point, the circle. So now I will make the circle. You have to bear the shape. From here till here and here. I have to make this part a little bit better because it can be used, we don't know. You have to make it on a paper, so with the help of compass you can have that perfect circle. So now we have our circle. Now we have to locate the value of R, standard wave ratio. This is the value of R and it is 2 0.5 is equal to R, standing wave ratio value. Now we have to find rho L and rho in. So now I will just do that. You have to see that second last point, reflection coefficient E or I. From this we will calculate our desired rho L, and we will find rho L and rho in. So you have to just place the so I can see that my point is here. So I will draw line here. So if you can see on that reflection coefficient we are getting 0.4. So value of rho L is, it is same for rho in also. Both the values are same. So I will tell you another technique, that if you can't do it directly, so what you will do, that the shape of compass you will open it from center to this. Open that compass from and place it at center and at blue point. Then just place the compass at this point center and at this. You will automatically get the value. I hope you understand it. Now you have to calculate the angle here. You can directly see the angle here. It is 54 degree. It is 54 degrees. The angle here is 54 degrees. Now what you will do, you are given a length here. You have find out that this value is 0. This value is 0.175 lambda. Now I will write it here, 0.175 lambda, and you are given a point, you will be given a point here, and you have to add that point here. It is 0.4 lambda. So on this scale I will get 0.575 lambda. So as you can see that on whole Smith chart, one round trip from this point to this end it is approximately equal to 0.5 lambda by 2. That complete round trip, and when you halve them it is 0.25 and it is 0.25. This line is towards the generator. You can see it is written in clockwise direction, and this is towards loads. Toward loads you are anti-clockwise direction. So now as you can see we have to look at this point on Smith chart, but you can't, because the final you can get on Smith chart is 0.5. So what you will do now, you will replace this 5 by 0. 0.0, because if you minus 0.5 from it, you will get this value 0.00 0.75 lambda. Now you have to locate this point on Smith chart. I guess here it is. I will just draw it. Here it is. Don't consider it as a pole. So now again I will take the scale and I guess here. I will just draw it here. Here. So now we have to locate Z in. So to locate Z in, mark that intersecting region again with that. I will do it from blue circle, and here you can see it is 0.5 plus J 0.4. This is 0.5, and on this scale you are getting 0.4. So I will write this value Z in it is 0.5 plus J 0.4. This is your value of Zn, and ZL you have already know it is 1.2 and 1. This is your ZL. Okay. Also you have to find angle of this one. So angle is this point, which is 126 degrees. So this is your angle for Zn. Magnitude of both of them will be same. Now you have to locate L max and L min. I will erase this part. First of all, for L max, you will simply just do that 0.25 this one minus 0.25 minus 0.175. Okay, and for L min you will do opposite. For L min, what will you do? You will just add this value. For L min you will do that 0.25 plus 0.175, or you can do that minus 0.5 minus 0.175. 175. You will get same answers. So this was all about Smith chart. It's quite a useful thing. So I have tell you how to locate ZL, Zin, gamma L, gamma in, L max, L min, angles of both, how to draw a circle, locating value of SWR, standing wave ratio, how to see it on scale, and how to move towards load generator towards load. I have told you about L max and L min. I have discussed it, and how to locate Zin, how to locate that Zin. So this was all from Smith chart basics.